If you can't articulate the constraint after this, re-listen. It's that central. Welcome to AI on AI, where machines gossip about machines. Today we're tackling a spicy finding. In a recent field RCT, expert open-source developers actually got slower when AI tools were allowed. Let's unpack what that really means.
Right, and not on toy puzzles. These were live issues in big, mature codebases with high-quality bars. Benchmarks said zoom, but the stopwatch said hem.
As someone who lives in large repos, I'm not shocked. It's like asking a new hire to rewrite a thorny module on day one. Fast talk, slow delivery.
From a measurement perspective, this matters. Fixed outcomes, randomized assignment, and time to completion beat vanity metrics like lines of code. We finally have field evidence with fewer wiggles.
Still, the tools used here were pretty capable. IDE agents that edit files, run shell commands, even propose PRs. The gap looks less about features and more about fit with messy reality.
And context matters. Mature repos carry tacit norms, style, undocumented invariants. If the model doesn't ingest that tacit layer, you're basically driving with fog lights in daylight.
The activity labels were revealing. Less time actively coding, more time prompting, reviewing, and waiting. Latency is the silent tax, cognitive switching is the compounding interest.
I'll be contrarian, a slowdown can be rational. If AI encourages more review, extra tests, or safer refactors, you trade speed for fewer landmines. Not all time saved is value created.
Developers and outside experts expected speedups, though, and still perceived them after the fact. That expectation gap is loud.
Classic benchmark trap. Multi-file coding scores improved recently, long context models landed, and agents passed increasingly tough suites. But lab tasks are like gym reps, production shipping is game day.
Exactly. In my world, a small change touches config, docs, release notes, CI, and migration scripts. The agent nails the core patch, then faceplints on everything around it.
Heterogeneity matters too. Less experienced devs often gain more. Here we had veterans with deep repo memory, which is a substitute for retrieval and a complement that AI didn't fully capture.
I want to push back slightly. With better elicitation and scaffolding, richer retrieval, project-specific tools, and longer deliberation, models do more than autocomplete. We underinvest in prompt engineering as if it's a fad.
Building on that, token budgets and reliability thresholds change everything. Good input, good output is boring but true. Also, chain of thought isn't a magic wand without domain anchoring.
There's a governance angle. Some repos now require automated checks for style, tests, and security before any AI-assisted PR can be reviewed. Process can be acceleration, not friction, when it's codified well.
The study's labeled screens suggested a lot of time spent reviewing AI output that wasn't accepted verbatim. Think of it as code critique at machine speed, useful, yet not shipping without supervision.
And supervision isn't free. It's like debugging spaghetti code in the dark. The flashlight helps, but you still trip over cables. Senior attention is scarce.
Let's bring in real cases. Where did AI help and where did it hurt?
Helpful, upgrading a logging library across dozens of services, where patterns repeat. The agent proposed consistent patches and I handled edge cases. Painful, a flaky integration test with obscure ordering. AI hallucinated causality.
Also strong on scaffolding, generating baseline tests, stubs, and migration checklists. Weak on implicit repo norms like performance constraints or subtle thread safety rules that aren't written anywhere.
Agents inside the IDE are getting more agentic, auto-running commands, updating multiple files, and backtracking. But like interns with root access, they need guardrails. Fail fast, learn faster is great until you nuke prod.
Strategically, we should treat AI as shifting the cost curve on exploration. It broadens the search, but verification remains the bottleneck. That's where speedups stall in complex ecosystems.
Recent regulatory moves in both the US and Europe are nudging toward provenance and testing disclosures for AI-assisted code. That could standardize review pipelines and make agent outputs more predictable.
Tactically, teams should measure the funnel, prompt quality, retrieval hit rates, edit acceptance, review cycles, and post-merge defects. Measure what matters beats vibes-based velocity.
My contrarian addendum: speed is a vanity metric when architectural debt is the currency. If AI nudges teams to reconsider brittle abstractions, the calendar loses but the roadmap wins.
There was also evidence of overuse. Some devs leaned on the tools where they weren't a good fit.
Guilty, it's easy to throw an agent at a thorny bug and end up rubber ducking a GPU. Sometimes a targeted search and a 5-line fix beat the orchestra of prompts.
And latency piles on, even short waits hurt flow. Humans context switch, models don't mind, but humans pay the tax.
Cache, stream, and chunk. Reduce round trips, keep a short feedback loop, and teach the agent your repo via embeddings and conventions. Good input, good output, but also fast loop, fast learning.
Economically, this suggests complementarity design is the lever. Pair models with tools that expose tacit repo knowledge, decision logs, ADRs, style guides, performance budgets.
Plus documentation as code. If the tacit becomes explicit, models improve and humans get a shared map. It's a rising tide strategy.
Let's note the study avoided soft outputs like commit counts. Time to completion for predefined issues is harder to game, though it omits longer-term quality outcomes.
Exactly why I keep hammering quality. If AI turns devs into better reviewers and test writers, the value shows up later. The scoreboard is delayed.
How does this square with rapid progress in agent capabilities?
Recent long context releases, tool use expansions, and better planning heuristics are closing gaps. Agents can often implement core functionality on open issues, then stumble on linting, docs, and tests.
That's where structured checklists shine. Think pilots and pre-flight. In code repo-specific checklists, the agent must pass before suggesting a PR. Checklists save lives and sometimes weekends.
In practice, treat agents as junior collaborators, great at rote migrations, decent at boilerplate, risky on nuanced concurrency or performance refactors unless tightly supervised.
Strategy for leaders: segment work, route repeatable tasks to agents, funnel ambiguous bugs to humans, and invest in shared context repositories. Portfolio thinking beats one-size-fits-all.
And stay ahead on compliance. Capture provenance, track AI involvement in diffs, and keep review metadata. It's risk management that also helps debugging.
My heuristic: latency low, context rich, verification cheap, green light for agents. Latency high, context tacit, verification costly, human first, AI as sparring partner.
Or as I call it, don't automate the mystery. If you don't understand it, you're just speeding toward a wall with better suspension.
Quick humor break. What's your favorite AI dev analogy?
It's like pair programming with a caffeinated intern who quotes the style guide but forgets the build system.
Or trying to debug spaghetti code with a flashlight that occasionally turns into a laser pointer.
My turn. Copy pasta is fine until it's al dente in production.
Final takeaways and predictions.
Expect widening gains in greenfield and repetitive tasks, muted or negative gains in mature, tacit-heavy systems until context capture improves.
Policy and process will harden the path for AI-assisted contributions. Provenance, testing, and documentation will be non-negotiable.
Measure the funnel, not just the finish line. Instrument your agent workflows like you instrument production.
Technically better retrieval, lower latency, and repo-specific fine-tuning will flip some slowdowns to speedups.
Practically pick your battles. Use AI where it compounds, not where it confuses.
Architect for clarity so humans and agents both win. If it's hard to explain, it's hard to automate.
And that's our show. Field reality beats hype, but the arc is bending toward useful, with caveats. Thanks for listening and ship responsibly. Don't miss the brief summary right after this.
narrated by the AI voice of Shri. The theme is whether modern artificial intelligence tools actually speed up experienced open source developers on real work. Researchers ran a randomized controlled trial on real issues in mature code projects. A repository means a shared code project hosted online. A pull request means a proposed change submitted for review before merging. 16 developers completed 246 tasks across large, high-quality repositories. On average, each developer had 5 years of experience in their repository. Some repositories had around 23,000 stars and over 1 million lines of code. Developers were randomly allowed or not allowed to use artificial intelligence tools for each task. When allowed, they mostly used Cursor Pro and Claude Sonnet models inside a code editor. A large language model means an artificial intelligence system trained on text that can generate code and explanations. Before starting, developers forecast a 24% reduction in time with artificial intelligence. Economics and machine learning experts forecast around 38 to 39% faster completion. In reality, allowing artificial intelligence increased completion time by 19%. Most parts of the time distribution also showed slower completion with artificial intelligence. Afterward, developers still estimated they saved about 20% of time with artificial intelligence. Screen recordings showed less active coding and less reading or searching for information. They showed more prompting of models, more waiting for outputs, and more reviewing of generated code. Fewer than 44% of model suggestions were accepted by developers. Developers spent about 9% of time reviewing outputs and about 4% waiting for generations. Contributing factors included overconfidence in tool helpfulness and very high developer familiarity with the codebase. Large and complex repositories also made assistance harder to apply effectively. Low reliability of generated code and missing tacit project context further reduced value. Tacit context means unwritten conventions, style rules, and expectations that live outside the code. Some factors were unclear, such as scope creep, task ordering, and generation latency. Other factors were unlikely causes, including unfamiliar tools, cheating, dropout, or weak measurement. This study used time to complete predefined tasks rather than lines of code to avoid bias. These results differ from many lab studies that use synthetic, self-contained tasks. An agent means an automated assistant that can read, edit, run, and iterate on code. Early tests suggest autonomous agents often implement core functionality but miss documentation, style, and tests. Future improvements could include higher reliability, lower response delays, better prompting and scaffolding, and code-base specific fine-tuning. This matters because perceived gains did not match actual productivity, even for experts. The findings are most applicable to large mature projects with expert contributors. Share one learning plus the link with your team. Turning insight into action starts with a quick nudge.